Hello. Right, the examiner wants you to know how geology made basically some parts of Britain. Today we're going to be looking at the upland areas. The upland areas are high up in the air, uplands. They're physically strong rocks, that's why they're still up. So today we're just looking at basically tectonics and the upland areas. Hopefully by the end of this little clip and the lesson that you're doing, you'll know those words that are on the keywords there. Right, geology. It's important to know what geology is. Geology is basically the rocks and stuff, right? That's it. Rocks and stuff over a very, very long time. Geography is about short term, geology long term. So let's crack on. In this period called the Carboniferous, around about 250, 300 million years ago, we, the British Isles, was where more or less that yellow star is now. We were underwater, but it was a very shallow sea, pretty much just above the equator, hot. Okay, so we're underwater, it's a warm, shallow sea, life everywhere. If you wanted to think about what it would have looked like, think about the Great Barrier Reef just off of Australia. Warm, shallow sea, coral reef. So how has that become a big cliff? Right. We're looking at the Carboniferous period. If you look at the little graph on the screen, you're looking at Carboniferous, which is on the right-hand column, about halfway down. It's just a name for the time scale. Times are so long, geologists have just given us names. So we're in a nice, shallow, warm sea. Now, how did that become Malham Cove? Well, at the bottom, there's loads of coral growing, but in the water, we've got life. You might be, mate. You might be. Oh dear. Bother. Right, so the trouble with life is life ends. You can see now that those little critters, let's say plankton, they're falling to the bottom. They're dead, they fall to the bottom. Repeated action over time. The examiner loves you to say repeated action over time. They build up. Okay, so this is happening over millions of years. They build up, they build up, they build up. Okay, that would ordinarily become a sedimentary rock, stuff, sediment that has just come out of the sea. So it builds up, and then because of the geology, the bit of land that we're on, tectonics, we are moving further north. So suddenly the sea is basically being pushed out. We are moving further north, not so hot, and we're now above the sea. All right, that ground, that mud or whatever is now above the sea and is becoming rock. Can you see that I've made it shrink there? So it's got smaller. That's because the water's being evaporated. All the little critters on top are crushing the critters below. It's becoming compact, so we call it consolidated. And you can see I've drawn in little bedding lines. Okay, so that now is one rock, one strata. I've turned it into rock. So now then we've moved away from the equator, away from the tropics. We're kind of moving further north, but we've now got tectonic uplift. That's what the arrows are showing. And that landmass now is being crushed. There's pressure on it, there's force, there's heat. So the sedimentary rock is now kind of being baked like in an oven, and we now call it metamorphic rock. It's physically much harder. It's resistant. And that is how, where that gentleman has stood 300 million years ago, he would have been underwater, stood on coral. That rock has been forced up high, about 300 meters up in the air now, okay, and it's